section is pretty much a review. Now, I'm not going to go along with the book. I'm going to cover a lot of stuff today, but it's going to be a lot of review. And what I'm going to cover first is graphing, because I think you can understand the whole concept of functions better if you do the graphing first. So we're going to talk about graphing the first few, well, a good portion of the class today. And I don't know what sections this is, but I think when we get through with today's class, you'll be able to handle the first couple of sections of chapter 7. So let's go over graphing rules before we go over graphing methods. Rules and properties. All right, first of all, when we graph something, to graph a straight line, it usually is in the form of a general form of a line. And the general form of a line, or the general equation of a line, is y is equal to mx plus b. And let's talk about those parts of a general form. Let's take our highlighter and let's highlight this y. And let's talk about what that y is. That y is what we call output, sorry. That's our output. In other words, when we put in x, we're going to get a number for y. So I'll go ahead and highlight the x. That x right there is our input. In other words, most of the time when you're dealing with a line and you're trying to graph that line, you need to put in x. Pick out numbers for x and you get y. And we'll talk about that when we get into how to graph. What is M? Well, let's take our highlighter and let's color M blue. M is what we call our slope. Slope is equal to vertical over horizontal. And we'll talk about that here in a few minutes. And then B is our y-intercept or vertical shift, whatever you want to call it. Now again, most of y'all have gone over this in pre-algebra or Algebra 1, so it's a review. And we're going to talk about slope next and how to calculate it or find it. And then we'll go over the 3 methods of graphing, and then we'll cover a couple more rules about how to find an equation of a line and all that good stuff. And then we'll go into functions, because then your mind will be in the gear of what is a function after we finish all this. So, let's talk about the slope. When we're talking about slope, usually you're talking about finding the slope, or you're talking about calculating the slope. Now, what's the difference between the two? Well, when you find the slope, usually you just solve for y and look for m. solve for y and look for m. Okay, that's the difference between finding the slope and calculating the slope. If I give you 2x plus 4y is equal to 6, and you need to find the slope, then you solve for y, and whatever's in the m spot, that is your slope. And we'll get to that. Calculating is using the formula m is equal to delta y over delta x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now that, calculating the slope, is when you're given 2 points or you're given a graph with 2 points designated, or you're just given a graph and you pick the 2 points. So finding the slope, usually you're just going to be given an equation and you solve for y. So that's the difference between the two. And we'll do a couple of examples here in just a second. Don't let me forget to do my doojicker over here.
So no matter what, you have to memorize the y equals mx plus b, and then you have to memorize if you're trying to find the slope, the y2 minus y1.
Exactly, yes. So right now, the two things that you need to know is you need to know the general form of a line, and you need to know the slope formula. Somebody tell me what the day is.
16.
I'm sorry, what?
16.
16? So to summarize, since I forgot to turn this on, this equation right here is what you need to know for the general form of a line, and you need to know what everything is. And then the second thing you need to know is this guy right here. Okay? So, let's talk about what they look like. Well, let's say that you're doing a homework problem, or you're doing a test or a homework or whatever, and it says find the slope. Most of the time it'll say find, and that's a clue that you're not going to calculate, you're going to solve for y. Or it may say calculate the slope, but most of the time when they want you to find the slope, that means you're not calculating. So, they give you this. 2x plus 4y is equal to 8. And when you see that equation, you automatically know that you need to solve for y. So, 4y is equal to negative 2x plus 8. Divide by 4, divide by 4, divide by 4. And y is equal to negative 1/2 x plus what?
2.
And you have the general form of a what? Line, and now you can find your slope, and your slope is negative what? Slope is equal to negative 1/2. You have just found the slope.
So it's just find the slope that you're looking for y.
Say again?
So it's like only when it says find the slope that you're looking for y.
Pretty much.
Do you ever solve for x?
Not when you're graphing, no. unless the formula wants you to, then we'll get to that in straight lines, but usually so that's how you find the slope. Another way that you can find the slope is if they give you a line and they say find the slope, and you put the vertical over the horizontal. But I usually don't show that because technically you're calculating it, because you're using numbers to find. Here you're not using numbers, you're using the equation to get the slope. You're not calculating. So let's talk about one where you calculate the slope. Okay, I didn't give you a equation, I gave you what? 2 points. And which way do we read?
X and Y.
Which way do we read?
Left to right.
Left to right. So this is x of 1, y sub 1. This is x of 2, y sub 2. Your first x, your first y, your second x, your second y. Now that's not rocket science. Just read left to right. And now you write your formula down. X of 1. And I tell all my students, whether they're in Math 120 or Math 101 or Math 140, whenever you plug and chug, I use parentheses. And I got 3 degrees, and I still use them, but of course we've got students with no degrees that don't have to use parentheses because evidently they know more than most math teachers. So, what are we going to plug in for y sub 2?
80.
What are we going to plug in for y sub 1? What are we going to plug in for x sub 2? And x sub 1. Now, of course, this is whole numbers and they're all positive. So really the parentheses are not that big of a deal. What do you use parentheses for? 2 things. Fractions and what? Negatives. That's why you use parentheses. So 8 minus 3 is what? 5. And 5 minus 2 is? And you have just calculated the slope. And that's how you calculate the slope. Now, how can I give you 2 points? Well, here I can give you 2 points like this. Or I can give you a graph and I take a red or green marker. The reason I'm using green is because this is what they do on the homework. And they give you 2 green dots right there. And they want you, and they have the graph numbered, of course. And they want you to use those green dots as what? Your points. So you find that point. This will be what? 0, negative 3. So 0 and the negative 3, comma 0. And this would be maybe 4, 0, comma 4. And that's what you would do. You would find those 2 points using your graph. And then you would take those 2 points and you would do just
So
like
it wouldn't matter which one came first or which one came
well, which way do you read?
But would you go
It doesn't matter, no, but which way do you read?
left to right?
So this one be your first one, this one be your second. Another way that I could give you is I could give you a graph and then what? You find the points. And what I tell students is if you've got a, and usually they have a grid background, usually. Make sure if you got a grid background, make sure you pick the points that are on the corners of your grid. Don't pick points that are in the middle because that's what?
Right.
Fractions, and you don't want to do that. Okay? So make sure, and I don't have a grid background, but make sure if you are not given the 2 green points and you have to find your own points, make sure that you pick points that are at the corners of your blocks, your grids, or as close as possible. Okay? Usually this is the least one given. That one's usually not given. This one's usually the one you see in this one. Okay? And that's how you find your slope. You either find it by solving for y, or you graph it, or you calculate it by using two what? And your formula right here. Okay? Now, there's a couple of other things I want to show you before we get to how to graph. And that is find an equation. When you see these three words, you're going to use the point-slope equation. Y minus y sub 1 is equal to m times x minus x sub 1. Now, that's the third most important thing to memorize. The first one is general form of a line. The second one is the slope equation. And the third one is point slope equation. When do you use this? Well, you use it when you see the directions. Find the what? Find a what? Find an equation. Now, let me ask you a question. What do you think you need to have to use the point-slope equation? You're going to need a slope and a point. Yep.
A point or points?
A point. Now, here's the three type of problems that you're going to see. One, you're going to be given 2 points. 2, a graph with 2 points, just like I showed you before. The green points. Or you're going to be given a point and a what? Slope. So there's your three types of questions. Which one do you think is the easiest?
Given 2 points.
Nope. Number 3. That's the easiest. The first two are the most challenging because you've got another step. Okay, so number 3 is the easiest. That's the one that is real, just plug and chug and simplify. The 1 and 2, well, if you're given a point or 2 points, what are we missing? Slope. So you got to calculate the slope. Then you got number 3 after you calculate the slope. So let's try one. Two, 3, 5, and 4. And I want you to find an equation for this line. So the first thing I want you to do is calculate what? The slope, because you need a point and a slope to do the point-slope equation. So, m, number 1, calculate the slope. And that's going to be m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, this is x sub 1, this is y sub 1, this is x sub 2, this is y sub 2. Parentheses minus parentheses over parentheses minus parentheses. 4 minus 3 over 5 minus what? 2. And that'll give us 1 what? 1/3. So our slope is equal to 1/3. Now tell me what we have up here. We have a point and a slope. We have a point and a slope. So what can we use? The point-slope equation. which point am I gonna pick? Why? Smaller numbers, easier what? Math. Now, if you like whips and chains, you pick 107 and 123 and a half. Why would you pick the bigger number? Because you like punishment, I guess. I love it when I have a 2 and a 3 here, and a -1/2 and a -3 right here, and the students pick the second one. I don't know why. Maybe they just like to get things wrong.
So it don't matter what you pick, even if you pick littler numbers.
Yeah, pick smaller numbers for easier math. It doesn't matter.
Like you're still gonna get the same answer.
You're still going to get the same answer. So, part 2. I'm going to pick 2, 3. And m is equal to 1/3. And I got to label this, so that's x sub 1, that's y sub 1. So, point slope equation says y minus what? Y sub 1, y sub 1 is equal to m times x minus parentheses. And that'll be a 3 here, a 1/3 here, and a 2 here. Now simplify and solve for y. So y is equal to 1/3 x minus 2/3 plus 9/3, and then y is equal to 1/3 x, and what's negative 2/3 plus 9/3? Now, whenever I do one of these problems, no matter what math I'm in, no matter what math I'm teaching, I always get, where did 9/3 come from? I don't know. You need to figure it out. All I got to say is I had to bring this -3 over here, and I'll let you figure it out. What do you have to add fractions?
Common denominators.
And I brought the 3 over 1, and I'll leave it at that. So, that is the equation going through these 2 points. Okay? Again, this should be a review, but if it's not, hopefully you're catching up on some of it. And that's how you use the point slope equation. Now, what if you're given a point and a slope? Well, if you're given a point and a slope, you just start right here. Because I have a point and then what? And you plug and chug. So that's why the point and the slope is the easiest, because you're already starting right here. If you're given 2 points, you have to start right here. Now, let's review. Here is the number 1 thing you need to remember. And that is the general form of a line. Number 2, you need to remember this guy. Slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 3, the point and slope equation. And it is used whenever you see find an equation in the directions. Now, there's a couple other properties you need to know,
Would we not, oh, never mind.
huh?
Just kidding.
And that is, this is another property. When y is equal to a number, it's parallel to the x-axis. Now let me ask you a question. If you have a line that's parallel to the x-axis, what kind of line is it?
Horizontal.
Good. That's a horizontal line. And the slope is equal to 0. So let's do a couple of examples. Y is equal to 2. Plot your y is equal to 2 and draw a horizontal line. That's it. Y is equal to -6. 1, 2, 3, 4, 5, 6. Horizontal line. Now the difference between these problems and y is equal to mx plus b is y is equal to mx plus b has a number, then it has x, then it has another number. And it has a y in front. This is just y is equal to a what? Just a number. No x, no b, no anything. Just a number. If y is equal to a number, then you have no slope, and it is a horizontal line.
So that means like no equation, nothing comes out like.
Y is equal to 4, y is equal to -1/2, y is equal to 3, y is equal to 107.
How many times will that happen? 'Cause usually they're all equations.
On the test, you're talking maybe 2 problems, because I'm gonna put the other ones, I'm gonna have 2 of these. One's gonna be y is equal to a number. What do you think the other one's gonna be?
Y is equal to a fraction.
X is equal to a number.
Oh, so even if x is just equal to a number.
X is equal to a number gives you a line that's parallel to the y-axis. And what kind of line is that? That's a vertical line. And a vertical line, the slope is undefined. Does not exist. And you need to write that down because that'll get you on the test. The easy question asks for the slope and y'all put 0. So you might want to, we'll color that pink. You need to remember that is
Oh,
not
that
equal
rhymes.
to that.
Vertical line, slope is undefined.
Yeah.
See, I got this.
There you go. Good. Now let's do an example. X is equal to 4. 1, 2, 3, 4. That's it. It's not rocket science.
So whatever axis is parallel, it's just.
The opposite. And you need to know one more rule before we get to, and that is when the slopes are equal, if you have 2 equations and you solve for y, and the slope of one is equal to the slope of the other, you have parallel lines. If m sub 1 times m sub 2 is equal to -1, in other words, if you solve for y, you got 2 equations, and you solve for y, and one slope is the opposite reciprocal of the other, opposite sign and the reciprocal of the other, then you have perpendicular lines. Let me give you an example of the first one. Example of parallel lines. y is equal to 4x plus 6. And y is equal to 4x plus 1. These two lines are parallel because the slopes are what? Slopes are equal. See? The example of perpendicular lines would be y is equal to 4x minus 2, and y is equal to negative 1/4 x plus 6. What is 4 times negative 1/4? Negative 1. See, opposite sign, and the reciprocal of 4 is 1/4. So whenever you see the opposite reciprocal, now remember, you need to write that down. I didn't say reciprocal. I said opposite reciprocal. There's the reciprocal, but the sign is also, that's a positive and that's a negative. It's got to be the opposite. And that's two examples of parallel and perpendicular lines. All right. Now let's move on to methods. And again, this should be a review because most of these methods are taught in Algebra 1. Method 1. Now, of course, I'm not going to call them what they call them, so I'll mention what they call them. I call it the chart plot method. Okay, they say graph using ordered pairs, graph using coordinates, graph using points. That's what they call it. Now we'll put in red that you use this method when y is by itself. And this method is usually the method that everybody knows because they had it in at least pre-algebra. First thing you do is make sure y is by itself. The second thing you do is you draw a chart. So the first thing you do is draw a chart. Put an X there and a Y there. Here's what everybody goes, oh yeah, I remember doing that back in pre-algebra. And then you pick, I tell students to pick 5 points. Lazy students, they don't pick 5 points and then they get mad when they get it wrong. But most of the time I tell students to pick 5 points. But what points do you pick, Hubert? Well, 90% of the time, I'm going to say 3, 90% of the time I pick -2, -1, 0, 1, and 2. Now, I want everybody to look at those 5 numbers and tell me why I picked those 5 numbers or why I wrote them like that. There's 3 or 4 reasons that I picked those 5 numbers, and there's 1 or 2 reasons that I wrote them like that.
Because then you get the y, like, all over the graph, you get the negatives.
Over both sides of the origin, I think that's what you're trying to say.
Yeah.
I get both sides of the origin, that's right. That's one reason. Give me another one.
They're small numbers.
Small numbers. What else? Why did I write them like that?
Small
From
and large.
Left to right. This is what y'all do. This is what I don't understand. All right? This is what y'all do as students. Let's say the average age here is 24, 25, okay? For 25 years, y'all have read from left to right. Right? Masalama, unless you're from the Middle East. Okay?
The Arabic.
Okay? All right? This is what y'all do. All right, I need to pick 5 points. Let's go 4, -6, -2, 0, 3, -4. That's what y'all do. And then y'all wonder Why? Y'all can't do math. Y'all read from left to right for 25 years, and you take and you do that when you write down numbers for your points. Don't make any sense. What am I trying to tell you to do? Whenever you do math, be consistent. Don't go all over the place like this, because when you go all over the place like this, your brain is going all over the place too. So, let's quit doing this trash, because that's what it is. It's trash. Don't do it. Pick these 5 points 90% of the time. What about the other 10% of the time? Well, the other 10% of the time, you're going to pick multiples of the what? Denominator. Hubert, what are you talking about? Well, I'm going to go to another page. So, if you want to go to another page, because I'm going to do an example on this page, but I'm going to go to another page, and we're going to do a couple of experiments. Y is equal to 1/2 x plus blank. Y is equal to 1/3 x plus blank. I'm going to skip around. Y is equal to 1/6 x plus blank. Y is equal to 1/8 x plus blank. Y is equal to 1/11 x plus blank. Y is equal to 1/13 x plus blank. All of these problems, I just picked 6 out. Of course, you got 12, 15 that you could go, because everybody knows your multiplication tables. Up to at least 15 you should. If you don't, then you didn't get your money's worth. So what is my multiples that I'm going to use with 2, 1/2? I'm going to use multiples of 2, which would be -4, -2, 0, 2, and 4. What about 3? -6, -3, 0, 3, and 6. What about 6? -12, Hubert, -6, 0, 6, and 12. What about 8? -16, -8, 0, 8, and 16. What about 11? -22, -11, 0, 11, and 22. How about 13? -26, -13, 0, 13, and 26. And what do I do when I use multiples of the denominator? What happens to the fraction? It cancels. You got whole numbers. So let's do one. Let's say this is 1/2 plus 4. Well, what's -4 divided by 2? And -2 plus 4 is? What's -2 divided by 2? -1, Hubert. What's -1 plus 4? 3. 0 times anything is 0, plus 4 is 4. Two over 2 is 1 plus 4 is 5. And 4 divided by 2 is 2 plus 4 is 6. How many of you don't have to raise your hands, how many of you have done these problems before and got fractions over there? Use multiples of the denominator.
How'd you get, I don't understand, I'm lost.
Where?
How'd you get the 4?
What for?
1/2 x plus 4.
I just made it up. I just made these up. These are examples. I just made them up.
But you can put any number in the blank, right?
Yeah. Oh, yeah. Let me give you. Okay. Y is equal to 1/3 x plus 3. There's your example right there. So what would you use?
Multiple of 3.
What would that be?
6.
-6.
-6, -3, 0, 3, and 6.
Okay. Now plug and chug. -6 divided by 3.
-2.
-2 plus 3. 1.
Negative, okay.
Negative 3 divided by 3 is negative 1, plus 3 is 2. 0 plus 3. And then look, what can you do? Now you can deduce a pattern. 1, 2, 3. What do you think this is going to be?
4.
4 and 5.
No, but see, in my luck, I would think that too, and then it'd be like small wall.
I usually tell students to at least do 3 and then do the pattern for 2.
You know how in these examples you gave us a blank?
Yeah.
Well, how do you know to put that 3 in that blank up there?
You can put any.
Just made it up.
You
Put
can
any
put up
number.
I could
Any
put
number.
29 in there.
Yeah. You still get a whole number.
That's a big number, but yeah.
I don't know what we're searching for.
Huh?
I don't know what we're
No,
searching
no, this is just, this right here, just don't even worry about this. I was trying to get you to do this. Pick multiples of the denominator.
for. Okay.
It's a drill, okay?
Okay.
So if I gave you 1/9, what would you do?
Look for its denominator.
1/9
Negative
multiples,
18,
there you
negative
go.
9, 0. Okay.
If I gave you 15, negative 30, negative 15, 0, 30, 15 and 30. And that's what you would do. Not pick 1, 2, 3, and 4 because that would give you fractions for your y.
Okay.
Okay?
Was I going too far? I think I was going
Yeah,
too
you
far.
were
in my
going too
head.
far.
Okay.
All right? So if I gave you y is equal to negative 1/4 minus x minus 2, then you would not even worry about this.
Okay.
You would just pick negative 8, negative 4, 0, 4, and 8, and you would do the math. If you pick negative 2, negative 1, 0, 1, and 2, then you're going to have fractions.
So whenever you're looking for the dollars, you're always gonna put under the X 2 negative numbers, 0, and 2 positive numbers.
Pretty much, yeah. And it also gets you ready for nonlinear, because nonlinear means a crooked line or a curve, and you need at least 3 or more points. So this gets you ready for that, which we're going to go into here in a little bit.
You just need to make sure it covers both sides of.
Yeah, exactly. All right? Question on that? All right. So that's how you do the, and you get these points, and I'm not going to go through plotting these points because I think y'all know how to plot points. All right. So what's the second method? Well, remember the first method. The first method is pretty important for the section that we're in right now, chapter 7. The second method, and I'm just going to go over these real quickly, is the intercept method. And the intercept method, when do you use it? That's called using the x and y intercepts. When do you use it? Use it when y is not by itself. What do you do first? Well, let's give you an example first. 2x plus 4y is equal to 8. All right, there's an example of a method 2. First thing you do is you draw a big table. Big enough to put an equation on each side. All right? The second thing you do is you put x-intercept right here. Put 0 for y. Y-intercept right here. 0 for x. Now, the biggest thing you need to realize here is what I'm trying to teach you. And that is whether you're in marketing, business, math, calculus, I don't care what you're in. Whenever you want to find where a equation crosses the x and y axis, you always plug 0 in for the opposite coordinate. If you want to find the x-intercept in calculus on an equation, plug in 0 for y. If you want to find the y-intercept in business, you got an equation for business, you plug in 0 for x, and you'll find the y-intercept. And that's true no matter what application you're in. And that's what you need to learn with this. Whether you use it or not a lot, that's up to you. But what you're supposed to learn right here is that in any application, business, financial, personnel, I don't care what you're doing. If you've got a graph in a book, in a presentation, in anything, and you want to find where that graph crosses the x-axis, plug in 0 for y for the equation that they give you. If you want to find where it crosses the y-axis, plug in 0 for x. And that's what I'm trying to get you to learn. All right, so let's take this example right here. Does anybody notice how I wrote these two equations? Anybody notice anything about it?
They're the same.
Yeah, they're the same. But anybody notice how I wrote them in relation to my brackets? It's lined up. So all you got to do is just bring this 0 right there. Bring this x, this 0 right here, right there. Now, some people do this by covering up the term. That's a shortcut, and you can do that. If it ain't broke, don't fix it. All right? Some of you have to plug it in, so let's do that. 2x plus 4 times 0 is equal to 8. And what happens to that term right here? It goes out, and that leaves you with 2x is equal to 8, and x is equal to what?
4.
And that 4 goes where?
X coordinate.
Right there. And that's how you do. Now you do the second one. Two times 0 plus 4y is equal to 8. And that 0 term goes out. What is y equal to?
2.
And that 2 goes right there, and now you got 2 points to grab. Now, this is the problem students make. Why do you think I put this right here and this right here? Say again? Well, it's left to right. You're right. That's good. But why do you think I put it? I didn't have to write x-intercept up there.
So you know which coordinate you're solving for.
Exactly, and you know which one to plot. What do students mess up here? Anybody want to take a guess?
X and Y axis.
They plot the wrong point on the wrong axis. They do all of this correct, and they plot this on the y-axis, and they plot this on the x-axis. So that's why I put x-intercept here and y-intercept here. And if you give me this problem on the test, that's the first thing I'm going to do. Again, I have 3 degrees, but some students won't do that because they don't need it. I'm trying to put it in a little bit of perspective for you. Doesn't matter how much, sometimes you forget. I would highly suggest that you put those right there. Okay? And that's how you do the second method of graphing. The third method of graphing, again, the second and the third method of graphing is not that important to this section as the first method, but as I'm showing you how to graph, you need to get in that mindset, so we'll go ahead and do the third method.
But you a lot of times see a lot of the intercept.
Yeah, you do. You do.
It might not be in this section, but it doesn't mean it.
Yeah, you're going to see it. The third method is called, I call it building a line. And it's called graph using the point and y-intercept. Or graph using the slope and y-intercept, I'm sorry. Building a line. And I tell students to use this method when y is by itself. So you can use method 1 or method 3 when y is by itself. But I also tell students that this is the best one to use when your slope is a fraction. Even though I told you how the best thing to do, if you have a fraction with method 1, you use multiples of the what? Denominator. Now this one's even quicker. if you have a fraction. So this is the one I tell students to use. And students like to use this one, and teachers like to teach it because it involves the least amount of math. And that's why teachers teach it. Go figure. Anyway, first thing you do is you extract information from your general form of a line. Because y is by what? It's by itself, so it's in the general form. So you pick out the stuff you need. 1, extract info. Extract means what? Think of a tooth. Pull out. All right? So, A, you're going to pull out the y-intercept. What is the y-intercept? Well, it's going to be 0, comma, b. Whatever b is. B, or step B, not B, y-intercept, but B, step B, is you're going to find the direction of the slope. It's either going to be negative, left to right down, or positive, left to right what? Up. There's only 2 signs, and there's only 2 sides of the hill. What's those sides of the hill? Uphill and downhill. And C, your vertical over your horizontal. And then what's the second step? After you pull out the information, the second step is plot the y-intercept. 3, draw a trace line. And 4, plot your vertical over your horizontal.
What's next to the M where it says plus or minus, what's the L on?
Left to right.
Is this vertical over horizon? Is that rise?
Vertical
line?
over horizontal.
Is that where you hear,
I don't use that
you don't use rise and run? Okay.
because people think it goes up. When they think of rise, what do you think of?
Going up.
Yeah, and you don't have to.
That's what I've been taught.
Yeah, and I don't like that. Because you automatically think you have to go up. And that's what, in this right here, you get confused because you're thinking up and you can actually go down. And I don't like to use that word. I know, I'm weird. Okay, so let's do an example. Y is equal to negative 1/2 x plus 2. And that's the way you'll be given that. And it'll say graph using the slope and y-intercept. That's what it'll say. And if it says graph using the slope and y-intercept, and you don't use the slope and y-intercept, then on my homework and test, you'll get it wrong. Because I'm a very firm believer, if you have a screw, a 2-inch screw to put into a board, you're supposed to use a screwdriver, not a hammer. Okay, because if you use the hammer, it'll damage the wood and it'll damage the screw, and then when you hang something on the screw will come out because the threads are not in the wood like it's supposed to be. There's a reason for everything. And we do not have the intercept form. We do not have the building a line form, and we do not have the chart plot method just to piss y'all off as students. They each have a certain thing that helps you either for time or for simplicity. One of the two. We don't make them up just to make you mad. Okay? So, here is my information. A. What is B? 2. So 0, 2. That is our, and I'm gonna color code this. I'm gonna take my handy dandy green And I'm gonna take that, and I'm gonna put it right there. Okay? Hubert, where'd the y come from? I mean, where'd the 0 come from? What? It's the y-intercept. What is 0? X is always what? 0 with your y-intercept. I taught you that with the method 2. Okay? B. What is the direction of my slope? What sign of my slope? It's negative. That means it's left to right down. So I'm going to take my handy dandy pink marker. Oops, sorry, wrong thing. My pink highlighter. And I'm going to highlight this. Negative, that means left to right down. Operator error. There. And now I'm going to do the last part, which is your vertical over horizontal. And this is for some of your program students. They'll go, it's -1/2. No, it's not. It's 1/2. That's your vertical over your horizontal. Program students, they don't like that one. That's a negative supposed to be with that 1/2. That negative tells you one thing and one thing only. That negative tells you whether it's downhill or if it's positive, that means it's what? Uphill. That's all it tells you.
So on C, you're always just,
This is going to be this is going to be vertical over horizontal.
You're just
solid.
always going to put the number that's beside.
That's it. Now, if you want to make it more difficult, we can find ways to make it more difficult, but that's it. Now, let's plot my y-intercept. What is my y-intercept? 0, 2. So 0, 2, and I'm going to color that green. There. And I'm going to take a very light gray line, and I'm going to make it, let's see, there we go. And I'm going to color it gray, and I'm going to make it real light. Now, did y'all see how I just threw that line up there? Did I use a ruler? No. Did I make it a certain slope? No. Did I care whether it went through the point or not? No. It's a trace line. That's what that is. That tells you that your slope is going left to right, what? Down. Now, a lot of people say, I always get confused about that. Well, which way do we read?
Left to right.
Then put your car right here. What's that car doing? Y'all laugh, but what is that car going to do? It's going to go downhill. It's as simple as that. And people say, whoa. Left to right. You read from left to right for 25 years. Why do you want to start reading from right to left? Why do you want to start asking questions about right to left? All right. Now plot your vertical over horizontal. Start right here. I'm going to go up. 1. Which way did I go?
To the left.
What?
To the left.
To the left, because what?
It's negative.
No. I don't see a negative
You go
down there.
over 2.
Why did I go to the left? Because that's where my trace line is.
Okay, so the top number is up, and then the bottom number is always.
Vertical over horizontal. Well, let's say you don't want to go up. Let's say you want to go down. 1. Which way do we go?
Towards the trace line.
To the trace line. It's a miracle! No, you have to go negative.
Okay, but if the trace line wasn't there.
I love these program students. They are programmed like a robot. You can't do that. You'll have to go up because no, you have to go down because it's a negative. You are so programmed. Jody and Susie are on one side of this side of the seesaw, and Susie's on this side of the seesaw. Well, what if Jody wants to go the other side? He can't do it. Can't do it. You ever seen people like that? You can't put the X on the right-hand side of the equal sign. That's the same thing. People, the negative, right here, if it's positive, it means it goes left to right up. Simple as that.
Okay, but if the trace line wasn't there, top number. you
I
would-
don't deal without a trace line.
In our homework, it'll be there. I'm just, it's Monday.
Take your pencil and put it on the screen. Like that.
What if your trace line was parallel? Where are you getting that trace line from? I don't understand.
There's two sides of a hill.
Okay.
Okay, tell me this. Where is a hill that doesn't have a uphill or downhill?
Okay.
What is it called then?
Plain.
Okay, is that a hill? Is that a hill? Okay, it's not. So you're asking me, well, what is the parallel? There is no hill then. All right? What are we dealing with here? What is this called? What is M called? It's slope. What does a slope have to deal with?
A hill. Okay, so you didn't just make that up.
No.
You actually said, okay, I gotta go from left to right down.
Either
So
left to
that's
right
where you
down
got
or
that.
left to right up.
Just imagination, you just went,
Yeah.
okay. I
And
thought
then-
it was some sort of
No.
figure to get that hill.
No, it's all it tells you is that you're going down what?
To the right.
Downhill. That's it. I'll do one here in just a minute that's positive, and then we'll do it the other way. But what I'm trying to tell you is, don't think that this means you have to go left or you have to go down. Because students get confused because that negative is in front of this number. They don't know which one's negative, the -1 or the -2, and they get confused. So just take the negative out and just 1/2. And the trace line will tell you where to go. So let's go down.
But I'm saying, like, even if your trace line was not.
Go down one.
Over two.
Which way? Which way am I going to go?
To the right, 2 times?
Exactly.
Okay.
Let's go down one. Which way? Left to the right, 2.
Can you explain to me where the vertical over the horizontal came from in this problem? Like,
Right there. It will always be given to you, unless you got to calculate it. It's going to be right there. It's right in front of the X.
So throw back to 8th grade when we did.
That's
slope
basically,
is
yeah,
slope
pre-algebra.
is run, slope is rise over run.
That's where the programming started.
Okay,
I thought you
slope
were going to
is
say,
rise,
oh, this is back in 8th grade where we learned how to build a line. Yes, not when you started to learn how to be a robot. All right.
That's how
now-
I remember it, though. It works. And then we made teddy bears with
Yeah.
their little grass. Plant them all.
You know they came out with voice boxes for Build-A-Bears?
Go down and over 2, up and over 2, down and over 2, up and over 2, and basically your line is going like that. And once you draw your line, what do you do to your trace line? You erase
Let's
it.
erase it.
High five.
And hit delete. I don't know where delete is, but anyway, I'll just hit delete over here. Where's the? That's it. So let's do another one.
Oh, it's too similar to the next one.
Now remember, if it ain't broke, don't fix it. If you have your own way of doing it, that's fine. Just don't tell me about it, because I don't want to get frustrated. All right? Just like when I do this, 2x plus 2 is equal to 4x minus 3, and I say I want to keep my variable positive, so I take that 2x over here, and the lady on the 3rd row, she has a conniption and a heart attack because I took the 2x over here, and that's just unheard of. Well, that's the same thing with the negative. The negative just shows you left to right down. That's all it does. Just like this, it's just like saying, if you've got a daughter, a son, and his name is Jody, and the daughter named Susie, and you take them to Lindley Park and they get on the seesaw, that Jody has to sit on the left-hand side. And if Susie tries to get on the left-hand side, she's gonna explode. Well, that's what this woman that has a fit saying that 2X can't go over here, that's ridiculous. I'm sorry, I just have a couple of pet peeves. The 2X going to the right side is a pet peeve of mine. It's not a big deal. And the negative in front of a slope is not a big deal. So Y is equal to 1/2. Oh, let's do something different. Let's do 3/5. 3/5 X minus 2. All right, y'all do that one. All right, what's my y-intercept? And what is my sign of my slope?
Positive,
Left to right, what?
up.
And then what is my slope? 3/5. So we draw our handy dandy,
You're gonna
right?
make me start saying left, right, uphill.
Huh?
You're gonna make me start saying left, right, uphill.
There you go. And 0, -2, be right here. Take my handy dandy. Do that. And I'll use that gray slanted line again.
Do it off the chart.
Now, did I plan that, or did I sit there and plot it, or did I just throw it up there?
Threw it up there.
I just threw it up there. I didn't, you don't have to do that. You can
This is how the line goes.
do it that way. Do it that way. Do it that way. I don't care where you put it.
Just know.
Now, how do you know that it's a up? How do you know? Well, which way do you read?
Left to right.
Wait, sorry. This is the wrong one. There's my little car. What is that little car doing?
It looks like
It's going what?
Uphill.
It's as simple as that. And I know y'all think I'm crazy, but it's not that difficult.
it looks like a potato.
You want to draw a car?
That's okay.
All right. So now I just take my handy dandy black marker, and just to make people mad, I'm gonna go down because there's no negative over here, and that just messes with the program people. They just start, they start circuiting. So I'm gonna go down.
Start sparking.
Start circuiting. Yeah. 1, 2, 3. Now which way am I gonna go?
Left, right.
I'm gonna go this way because my trace lines is over here.
This is where I got confused.
Go down 1, 2, 3. Now, of course, it's easier when you got a graph. When you got little grid lines, mine is way off. Okay, for the programmed ones, go up 1, 2, 3. Our 3's right here, and then go over and your line is right there.
Yours
And
is
then you
pretty
can-
close.
Take that line out. Well, I'm trying to do something with it. There. I can't hit delete right now. Go ahead and hit delete. And that's how you draw the three types of graphs. All right, now, that's all review. Now let's go and let's put our pinkies up, because now you're going to do all of that, but you're going to hold your pinky up and call it a function,
Okay,
because that's a little different.
what's,
Let me ask you something else. While we're doing the review, let me ask you to do 2 or 3 things right quick from pre-algebra. Not graphing, but let's just do these 3 things. I want you to do 2x while I'm 2x plus 3, and I want you to add x minus 4. And then I want you to do 3x minus 6 minus 2x plus 7. And then I want you to multiply 2x times 3x minus 2. And then I want you to do x squared plus 2x divided by x. Do those 4 things right quick that you learned back in Algebra 1, pre-algebra. Okay, you should be finished here in just a second, because it shouldn't take you 15 minutes to do this. All right, what's 2x plus x? We'll do them in red. That way you can check your answer. What's 2x plus x?
3x,
Okay, so 3x, and what's 3 minus 4?
-1.
All right, so there's your first one. Any problem, you distribute the positive right here, positive 1, and a positive 1 right here, and then you combine like terms. Everybody happy? No problem. Let's do this one. What's 3x minus 2x?
1x,
And what's negative 6 minus 7?
-13.
Take the positive 1 here, and nothing changes, but what happens here? That negative 1 changes the whole world. And you get 3x minus 2x, and then negative 6 minus 7 is negative 13. What about this one? Distribute, what do you get? 6x squared minus what?
4x,
And everybody's happy. That's just your old distributive law and combining like terms, adding exponents. And then what do you get here? Subtract your exponents. Again, this is stuff that y'all learned back in pre-algebra and algebra 1. Okay, Hubert, what are you doing? Why are you doing all this? Well, everything that you're doing, 80% of what you're doing in chapter 7 is what we just did. Except, you gotta hold your pinky up. You gotta write it f of x. Okay? Let me show you. First of all, I'm gonna draw you don't have to draw what I'm drawing up here. But some of y'all might recognize, some of y'all gonna make fun of my drawing, but that's okay. I'm a pretty big boy. I can handle it. Oops, that's wrong. Got a little handle right here.
I was gonna say, if you're trying to draw blocks, you're way off.
Okay. Now, some of you may have been in a hotel before, and some of you may not have, but that's basically an ice box. You know, you lift out ice, scoop ice out of it. Nowadays, you put your card in the ice machine, and it drops it in the plastic bin, and then you put your cooler in there, and you lift the thing up.
There's
But-
some that sing,
Huh?
there's some that sing.
Okay, all right. Now, the old-timey ice machine, is basically this thing that you flip the lap and you've got a scooper in there and you scoop whatever you want out. Now, what goes into this thing? Water. And what comes out of it? Ice. It is working, ice. Okay?
Maybe like the drain, like,
Yeah, okay, I know what you're thinking. You're thinking water, yeah, condensation. But I'm thinking more of output, okay? And input. Let me ask you a question. On the farm, we have a lot of 5-gallon buckets because hydraulic OIL comes in 5-gallon buckets. And when you have a busted hydraulic line, all the hydraulic fluid goes out by the time you shut down the tractor. So you have to get these 5-gallon buckets of OIL and put back in the tractor. So we have lots of 5-gallon buckets. What if I take a 5-gallon bucket of water and I put it into a funnel and cut the water line off, and I take that 5 gallons of water and I put into this ice machine? What will I get out of the ice machine? How much? 5 gallons worth, right? Does anybody have a problem with that? I'll get 5 gallons worth of ice. What if I put in 10 gallons of water? I'll get 10 gallons. What if I put in 3 gallons of cherry Kool-Aid?
3 gallons.
I'll get 3. Yeah, I'll get 3 gallons of cherry ice. So what can you tell me from this little scenario?
You know, it depends on the functional X.
The input. The input tells you what you get with output, right? You get out of it what you what?
put into it.
There you go. All right? You get out of it. Remember that. You get out of it what you put into it. Now, what in the world does this have to do with functions? Well, I'm fixing to tell you. The H2O, let's change that to input. Or we could change it to, what's our input with functions? X. Our output, we'll take the ice out and we'll put output. What is output in functions? Y. Then what is this? This is the actual function. This is your 2x plus 3. Now before, we called it an equation. Now, you pick your pinky up and you call it a function of x. That's the only difference between what you learned back in pre-algebra and what you're learning now. There is no difference. Oh, something else. Somebody give me a one-word name for input.
Information.
Information, good, but that's not what I'm looking for. That's a good answer, though. Starts with a D. No? Good answer. Huh? Good job. I'm very impressed. Take red. That's your input. Then tell me what the Y is.
That's the range.
The range. We'll put that in green. So, what can you tell me about the domain? It always will deal with what? The X. And what will the range always deal with? The Y. You need to write that down. You need to put bold letters. You need to highlight it. Now, let me ask you a question. What if I put in 100 gallons of water? What am I going to get out?
100 gallons ice.
100 gallons of ice. I keep asking you that for a reason. In pre-algebra, you were given this. Oops, sorry. Oops, sorry. I don't know what I'm doing. In pre-algebra, you were given y is equal to 2x plus 3, and you were told to do this, and you were told to do this, and you went through, and -2 times -2 is -4, plus 3 is -1, -2 plus 3 is 1, 0 plus 3 is 3, and 1 plus 3 is 5, and 2 plus 3 is 7. And y'all check my math on that. Everybody agree with that? Now, hold your pinky up. Now, you're going to say f of x is equal to 2x plus 3. F of -2 is equal to -1. F of -1 is equal to 1. F of 0 is equal to 3. F of 1 is equal to 5. And F of 2 is equal to 7. Somebody tell me, what is the difference in what you did in pre-algebra and what you did just now?
It ain't no different.
It ain't no different. In fact, you did the domain and range back in pre-algebra. What's the domain here?
-2.
2. What's your domain here? -2 to 2. What's your range? You're supposed to say that.
-1 to 7.
There you go. What's your range? But in this section, you're introduced domain and range. There it is. We are in chapter 7 now. I'm sorry, pre-algebra. Now we're in chapter 7. Now, if you go to your handy-dandy textbook, y'all look in your handy-dandy textbook, and you'll see your, they took my idea. They don't call it an ice machine. They call it put in circles and get out squares. Actually, I've used a hay baler. I've used a hay baler and I've used a bicycle.
I like that one because I use one at work, so it makes sense.
But we just went over 7.1. Now, you can also find your domain and range graphically. let's take this. I want you to graph these points right quick. Do that. Just graph it on a piece of notebook paper. Just graph those 5 points, whether you're in pre-algebra or chapter 7. Graph those points. This is where we're going to bring it home now. You're going to actually see the domain and range. So I need to do this. Let's see if I can do this. Nope. See if I can get this. Oh my gosh, can y'all believe that? I tell you what, y'all are impressed, aren't you? Just learning all kinds of stuff on this thing. Oops. All right. So I'm going to take my handy dandy graph here, and I'm going to draw a line there, and I'm going to draw a line here. Somebody give me my points. Let's go with red. All right, give me my first left point.
-2.
-2 and what?
-1.
All right, what's the next one? -1 and what?
1.
Next one?
0, 3.
1, 2, 3. Next one?
1 and 5.
3, 4, 5. And then the next one, 2 and what?
7.
That's 5, 6, 7. Now I'm going to take my handy dandy red marker and, oh well, so much for the red, but there it is. Now, I have a graph here, and I want you to, don't even look at your graph anymore. I mean, the plotted points, I want you to look at this graph. What points on the x-axis are being used for this graph? From -2 to where?
-1.
There's your domain. I'm showing you how to find it graphically. You're looking at this graph. All right? This graph has been given to you on a test, and there's nothing else. It says find the domain and range. And what you do is you draw a line, imaginary line, from this far left point, because we read for which way?
That's right.
So I start from the left, and I draw an imaginary line up to this point. And there's my x, there's my beginning of my x. And then this point, I draw a line, and there's your end. So your domain is from -2 to what? Positive 2. Isn't that what you said a while ago when we didn't do it graphically? Then what is your range? Well, you take your handy dandy graph, and your range is, take your highlighter, is going to be from here to there.
Now, why wouldn't it be, like, okay, I get the -1, but since, it goes all the way up to the top, why wouldn't it stop right where it crosses the Y intersection, or the Y line?
Because the x values give you the what? What does the x values give you?
Domain.
But what does it produce? What does your domain produce? The what?
Your x-intercept?
The range. 10 gallons of 10 gallons of water produces what? 10 gallons of ice. -2 to +2 produces what? -1 to what?
7.
To 7. Okay, let's go back. -2 to +2. I'm sorry, wrong color. Hold on. -2 +2 produces -1 to what? +7.
So whatever the raw points are, that's gonna be your range, all the way up.
Good job. All right, so let's do something different. Oops. Okay, why didn't it? There. All right, you got your graph here. Y'all ready for this? Let's go with, let's see if I can do this. I'm trying, people. Just,
Are you trying to make a V?
I'm trying. There we go. Okay, well, that's what I want. I wanted that, but I don't want this. So just ignore that little piece right there. I'll try to, I don't know why I won't. There. Okay. Now look at that one. I want you to draw this on your, try to draw it as best you can. And I want you to tell me what the domain and the range is. You can draw your own version. How about that? I mean, it doesn't have to be perfect. Just make sure it starts up there, it crosses right here, and it ends up over here somewhere. Let's see, I'm going to use a straight line. I'm going to use yeller. I'll make it big. Okay, there's my domain. And I'm going to do my range now. Okay, there's my domain and range. Now let's look and see what my domain is. My domain, 1, 2, 3, 4, is from -4 to what? To 7.
Alright, so domain is just how wide it goes, and then range is just how tall it goes.
So that 5 gallons of water produces 5 gallons of ice. Now what's our 5 gallons of ice? -1, I'm gonna take your word for it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all there is to it. So our domain is from -4 to what? 7. Why did I use brackets?
Because it's not really.
Because it's inclusive of the number at the end, the -4 and the +7. Because if there's nothing here, it's assumed to be solid what? Solid dots, solid closed circles, if there's nothing there. It's assumed to be closed circles. What if it was arrows? Then it'd be -infinity to +infinity because it doesn't stop. Okay, we'll do one here in just a second. What if it's open circles? Then what would these be? Parentheses. So what's my range?
-1 to 10.
-1 to 10. And that's how you do domain and range. So let's do another one.
You're gonna get lots of questions. So
I've
you
just
need
never
your
had a class this long in all of my life.
Hold on, I gotta draw another one. Hold on just a second. And I'll get your question. Oops. Sorry.
We can do.
These girls on my cheer team are insane. They're talking about taking a group trip to 9 rounds.
I don't know what you're talking about. I don't even know what 9 rounds is.
Just a gym.
Oh, I was like, I'm confused.
Wow.
Not finished.
You're trying to throw all kinds of WTFs in there.
Yay!
Actually, it's the easiest one. What's your domain? -infinity to
Positive infinity.
+infinity. Why?
Got arrows there.
Because the arrowheads, they keep going and going and going. Think of a baseball in space. You throw a baseball in space, where's it going to stop?
Not where.
It's not. Theoretically, of course, somebody say, oh, hit a meteor. Yeah, it probably will. But theoretically, if you throw a baseball in space, something has to stop it because it will never stop. It will keep going and going and going. This keeps going and going and going and going. All the x values are being used up because of what?
The arrows.
The arrows. Write that down. What about the range? Now the range isn't -infinity to +infinity. Well, yes it is, because of this arrowhead over here. I was thinking of a parabola. So range is from -infinity to what? +infinity. You can also say all real numbers for both.
Tell me that again about the range, what'd you say?
-infinity, +infinity. Because
Just like
this
that.
arrow keeps what?
Go.
It keeps going, so all the y's are taken up too.
So the range is also -infinity, positive.
-infinity, positive, or all real numbers for both. Domain is all real numbers, range is all real numbers. Either way you want to write it. So, let's change it a little bit.
Okay, so when the arrows are on the line, the range will always be all real numbers, and so will the domain always be all real numbers.
Not always. I'm going to
Just
show
the
you an
range.
example here in just a minute where it's not.
No, but the range will just, it won't always be all real numbers.
Just bear with me. I'm here.
Cause what were we we supposed to write down then? I don't either, this one.
I said, you can use all real numbers, or you can use negative infinity to positive infinity.
No, but that won't always be the case.
Not always. Trust me, just bear with me. Okay, find the domain and range. These are open circles. Domain and range.
What did we say about open circles?
Hmm?
It includes that number, but.
No,
it's
it does not. That means you use parentheses. Open circles mean it's not inclusive of the number at the end.
So would it just be -2
Hmm?
to 9?
I don't know. It looks like -3. 1, 2, 3. -3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So your domain is -3 to 9, and then what goes on both sides? Parentheses, because of the open circles. So that 5 gallons of water gives you what 5 gallons, be careful here, but what 5 gallons of ice? Well, your domain, your range is going from 0 to, hold on, let me go through the bureaucracy. Well, this is supposed to be up here, sorry. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your range goes from what?
0 to 10.
Good. 0 to 10. Now, the 10, since I did put it on that line right there, it is inclusive. So that would be, and the 0 is inclusive, so that would be 0 to 10, because it does touch those lines.
If it didn't touch those lines,
Then, well, you wouldn't be able to tell it. Just pretty much, you'll get it. You'll get it after you do some problems, you'll get it. Let me show you an example of one
So domain,
that you would not be inclusive.
so
Let
domain
me,
you use parentheses, range you use brackets.
huh? You're trying to patternize. Do
No.
not do that.
No, I'm saying like on the domain you use the parentheses, and on the range you use the brackets.
The domain, right here, it's got open circles here and here. The range, is that touching that line?
yep.
Yes. This is touching this line, so you can use that and you can use this. So that's why I've got brackets. Here's an example of one that I'm just trying to use the grid. Just hold on. All right, try that one. Those are open circles, not closed circles. there's your domain. There's your range. What's my domain? 1 to 7. I'm gonna take y'all's word for it. Brackets or circles? I meant parentheses.
Parentheses.
And then your range,
2 to, I couldn't see.
2 to 9. I'm gonna take your word for it. And what do they get?
Parentheses.
Parentheses, because they have open circles. The difference in the one while ago is that you had open circles at the end of the X's, but you had points that were actually touching the points on the end of your range. So you gotta be careful and watch for things like that. $12.03, is it 12:20 or 12:10 class is over?
12:20.
Okay.
Okay, explain that one more time, about why the range only got the parentheses at one time.
They get the parentheses because they have the open dots on the points.
Right there.
But why last time?
And then the brackets, are you talking about why they got brackets? Because it was a curved line and the top of the line actually like touched
Mm-hmm.
a point on the graph. It wasn't like an ending, it was a part of the line still.
And I can't go back and get it. I guess I could, but I don't know if it'll do it or
Like-
not.
Some real bad, but like the curve, this guy was touching the line. Then they would get brackets. And then if they were arrows, if they're arrows, they get all real numbers for both, because it just goes on and on.
All right, now this one right here, and you don't have to draw this one, I'm just trying to answer your question. All right, what is the domain here? -4 to what?
Positive.
-4 to 3. And what do they get?
Parentheses.
Because of the open circles. All right, what about your range? From 1, 2, 3, 4, 5, 6, 7, 8 to 8. And what does this one get? Parentheses, what does this get?
Oh,
Bracket.
tricky.
See what I'm saying?
Explain it one more time.
So
Why?
you gotta watch for.
Y'all are not looking, what y'all are not doing, this is what y'all are not doing, I'm not fussing. I'm just telling you what you're not doing. Get your highlighter. I'm trying to do 2 or 3 things at one time, I'm trying to think, and it's not working too good. Okay. Take your highlighter and go from there to there. And then ask yourself, do you have open circles or closed circles? So you get.
So they both have to be open. And then when you.
Now, we're gonna go get our green, and we're gonna do our range.
An open circle and a line,
There you go.
so you have a parentheses and a bracket.
There you go.
So on the range, it physically has to touch for it to get a parentheses.
Exactly. Question?
Who, me?
Yeah,
No, we just click what she just said.
good,
She said it.
okay.
So that's why the 8,
I'm
but
for-
why, okay, wait. Why does the 8 not get a parentheses and why should the 1 should get, since it don't physically touch, it should get the bracket?
Did I touch 1 with open circle?
It doesn't line.
No, you don't. So it gets, anything with an open circle or doesn't touch gets a parenthesis. Anything that touches gets a bracket.
Okay. See, you don't put things in layman's terms.
I'm trying. All right. Now let's look at the next couple of sections because that's basically 7.1. Let's look.
Don't forget roll call.
I know. 7.2. Thank you. Domain and range. So that's 7.2. Let's look at a couple of their questions.
Now, will they go with,
Oh my, look at there. Look at there. They use highlights too.
are you doing this on purpose?
Yeah.
Hey, what happens with the parentheses or brackets when you have arrows with lines that continue going on? You do the same thing, just with infinity signs?
I'm fixing to pull one up and see what they do. All right, look at 23. What would 23 be?
All real numbers,
There you go, for range and
domain.
domain.
And so that's what you would write?
Yeah.
You couldn't do infinity?
You could do negative infinity, positive infinity, and negative infinity to positive infinity. Yes, you could do that.
And those would need brackets.
No,
They would
infinity
need
always
parentheses.
gets parentheses because you can't touch it.
Okay.
Infinity
parentheses.
always gets it. All right, what about number 20? What's the domain for number 20?
Negative
-2
two.
to +5.
And brackets or parentheses?
Brackets.
Brackets, because you got closed circles. What about range?
-2 to +4.
With
Bracket.
brackets. So yeah, I told you y'all get it. How about number 17?
-3 to 4.
With a -4 to
3.
3, and then -3 to,
4.
and does it get brackets or parentheses?
Brackets.
I don't see any open circles. I see one, but I'm not going to worry about that one right now because that's not what I would give you on a test. Let's see the next page. See the, no, they don't have any. So
So what made it do the, parentheses and then the bracket on the other one?
what other?
I don't know, which is did, or did one you were trying to show me?
I had open circles.
But if they have closed, they're always both be brackets. If they physically cross.
Yep. Graphs of functions. Golly, look at there. Y is equal to mx plus b, and y minus y sub 1 is equal to m times x minus x sub 1. What are those? You don't have to answer that.
I don't know, I like it shushed.
Who?
You, I was like.
I've
hey,
never
that's
should.
what
Did I tell you hush?
No, you're like, oh my gosh, look at 22. I was like, I just asked a question.
Well, you won't let me figure. You won't let me get there. Look at there. Y is equal to 3x plus 2. You should know how to graph that. I'm trying to see how far I've covered. So just bear with me for a second.
So if it's a closed circle, you write it in parentheses. If it's a line, you write it in brackets. And if it's an open circle, you write it in parentheses.
Just remember this. If it touches, it's a closed bracket. If it doesn't touch it, it's parentheses. And you can't touch infinity.
Every time you say infinity, I always want to say to infinity and beyond.
I just did that.
I've done it every time.
All right, let's do number 39. I want you to graph number 39, and I want you to tell me the domain and the range. And this is 7.3, so we've covered 7.1 through 7.3. And number 39 says f of x, or y, is equal to 1/3 x minus 7. 1/3 x minus 7. And while y'all are doing that, I will make sure the bureaucrats are happy. And make sure everybody's here. Okay. Okay, Miss Black is here, Miss Bozeman is here, Miss Coward is here, Mr. Gray is here, Miss Grogan is here, Miss Holly is here, Miss Jones is here, Miss Keller is here, Mr. Mahaney is not here. Miss Rose is here, Mr. Sabacool is here, Mr. Skipper is here, Miss Wilson is not here. I wonder why I'm so quiet in here. And Miss is here. So, let me take my handy dandy whiteboard. 1/3 x minus 7. One-third x minus 7. Y is equal to 1/3 x minus 7. And if you don't like to do that, raise your pinky up and go,
F of x is equal to 1/3 x minus 7.
because aren't they the same thing? They're the exact same thing. Only, and this is for everybody that didn't pick this up, here, what did I tell y'all to use?
Well, the numerators.
-6, -3, 0, 3, and 6. And that's going to be -6 divided by 3 is -2. -2 minus 7 is -9. -3 be -1. -1 minus 7 is -8. -7, you see the pattern. Negative what? 6 and -5. And of course, if you hold your pinky up, f of -6 is equal to -9. F of -3 is equal to -8. F of 0 is equal to -7. F of 3 is equal to -6. And f of 6 is equal to -5. So, 6 of 1, half dozen of what? Y'all's parents didn't teach y'all anything. 6 of 1, half dozen the other. Y'all don't have any idea what I'm talking about. What is 6 eggs? A half dozen.
Oh, eggs.
Oh,
I thought you were saying X.
I did too.
Yeah.
I was like, what's he talking
I
about?
was like, you done lost me?
We just don't understand what you're saying. Continue on.
Don't do your face hard.
6 of 1, half dozen the other. How do you get X out of that?
Because you said 6 of eggs. And it kind of sounded like 6 of X.
People at home, y'all see what I'm having to deal with up here? Okay.
At least we're not that bad off.
Huh?
I said, at least we're not that bad off.
There's an old saying, 6 of 1, half dozen of the other. What does that mean? They're both what?
The same.
The same. Can't believe y'all didn't know that saying.
You
Google
didn't
it.
grow up in the 30s, so.
No, I didn't either. I grew up in the 60s. I didn't grow up in the 30s.
So my question is, how do you find the domain and the range when it could keep going?
The domain here, well, that's a good question. The domain will be signified by a graph. It will be designated by an instructor, or it will be designated by the directions. Okay? If it's not, then it's going to be all real numbers or whatever the graph that they give you. But what they're wanting you to see is that when you do a graph, the x values are the domain and the y values are your range. That's what they're trying to get you to understand. In this problem, we're dealing with this right here. So our domain is -6 to +6, and our range is -9 to what? -5. Now, if I put arrows on the end of that, then what will our range and domain be? Well, we're going to look at that. All right? I'm gonna draw my handy dandy graph. Well, we just gonna do this because I don't feel like changing it. So y'all just have to deal with the green. All right, -6, -9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. -3, -8. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. 0, -7. That's 8. 0, -7. Be right in there. And then 3, -6. And then 6, -5. Whatever. Go away. All right. So our line now. Whatever. Okay, the whole point is that y'all see how to graph. Hold on, I'm gonna try to fix this, but it's not letting me. I was gonna try to rotate it. No, it's not gonna let me rotate it. No sneezing.
Sorry.
There. That's close enough. Now, let me ask y'all a question. If I was to do this, there, what is my domain and range?
-3 to 6.
-6
I'm
to
sorry.
what? -6.
I thought you meant something.
-6 to 6, basically, right there. Oh, Lord.
You and technology are done.
I'm trying to get y'all to see all this stuff, and it's just, I'm having to switch from left to right, and of course y'all don't appreciate it, but you know.
Oh, thank you so much. You got it.
There you go. -6 to what?
6.
+6. And then what's my range? Well, I'll take my pink one. Be careful here, because your range is only what?
-9 to -5.
Yeah, it's only right there. So here, now what if I did this? What if I took and did that? What's my domain? All real numbers. What's my range? All real numbers. What if I did this? What if I put an open circle there and an open circle there?
Use parentheses.
Then you use parentheses on your numbers. See? That's how it works.
In the homework, if they give us just a function, how do we know if they have open circles or not? Do they have to physically like?
Well, they will designate that in the directions, or I would designate that on the test or homework. All right, your homework is to work on 7.1 through 7.3. Adios, amigos.